Hi everyone, welcome back to another week of STEMpower at home. Today we will be doing an experiment about sound. As you might already know, sound travels in waves. When a glass jar is tapped on the side with a spoon, the molecules of the jar vibrate. This then causes the air around the jar to vibrate, creating a sound wave. If you put water in a jar, the vibrations have to travel through the water too. As a result, the vibrations are sound waves and sound are changed. Because water molecules are packed closely together, it takes a lot of energy to get sound to travel through them. So, increasing the amount of water causes slower vibrations, slower sound waves, and therefore a lower pitch. When you lower the pitch, the waves are more spread out, meaning that they have a larger wavelength or a lower frequency, which is the number of waves that pass through in a second. The wavelength is the distance between two peaks of a wave. Now let's have some fun experimenting with the range of sounds that jars can make. For this experiment, you will need as many glass jars as you would like to use. Some examples could be jam, pickle jars, or other ones you find, a metal spoon, and glass beverage bottles, but this is optional. First, fill your jars with varying amounts of water. Tap them on the side to test their pitch. If you have multiple jars, try making enough notes to make a song. If you want, try this experiment with bottles. When you blow across a bottle like you would play a flute, the air inside the bottle vibrates and creates sound waves. It may be difficult, so don't be discouraged if you don't get it the first try. What's interesting is that the pitch made when you blow into a bottle and when you hit the same bottle with the same amount of water on the side are only the same if you fill the bottle to about 1/3 of its volume. Here's why. When you blow across a bottle, the pitch depends on how much air there is in the bottle. This is because the sound waves creating the sound are made from the air molecules' vibrations. When the bottle is less than 1/3 full, the air molecules vibrate less, produce slower sound waves, and a slower pitch because there are many water molecules for your breath to spread out on. When the bottle is more than 1/3 full, the air molecules vibrate more, produce faster sound waves, and a sound higher in pitch because the breath's energy is concentrated on the smaller amount of air molecules. Now that we've experimented with these musical jars, let's discuss. The first question is, what patterns did you notice when you changed the amount of water in the jars? You most likely found that when there was more water in the jar, the sound you made when you tapped it was lower. This is because it's harder for sound waves to travel through water than through air, which made the wavelength larger and therefore the sound deeper. The second discussion question is, based on our definitions of frequency and wavelength, what is the relationship between them? When frequency is higher, the wavelength is shorter. This is because when you have more waves going by in a second, they have to be more tightly packed together. It also works the other way around. As wavelength increases or gets larger, the frequency decreases. Thanks for doing this experiment with me, and I hope you enjoy learning about sound waves. Let us know what song you tried to make with your jars in the comments. If you want to watch one of our other videos, click here or click here to subscribe. See you next time. Bye!